My name is Joaquin, and I'm here to help you learn about the truth table. Now, what is a truth table? A truth table is a mathematical table used in logic, specifically in connection with Boolean algebra, Boolean functions, etc. How many rows we are going to have. So let's say you have two variables like this P and Q. Okay, you are going to compare both so that we could know what is the final answer on the truth table using these. So this is the 2, which can be labeled as rather K for the 2, or it could be 4 or 3, and then the number of the variables that you have. Currently we have 2, so we raise 2 to 2, so that's like K to 2, then that will equal to the 4 based on what we have here. So since we start with 4, that means we will have 4 rows here, meaning the first row, which is Q, will start from right to left. Okay, so Q is the rightmost row, so we start with 1 0 1 0. You see the pattern? It's like 1, then we start with 2 now, so it's 1 1 0 0. So for example, if we have another one here, let's say R, the third row, since it's already the third row, that would have around 3, then back to being false. Okay, but since we have only 2 here, 1, by the way, is true, 0 is false. In other truth tables, we can label it as true, false, or true, true, false, false. But I rather have this because it's much easier for me. So you can interpret it any way you want. So 1 0 1 0 for the first row, second row 1 1 0 0. Usually we have logical operators for this, and we have around 4 logical or 5 logical operators in the truth table. So first, the most common one or the easiest one would be the negation, or rather this can be written as Q not as well. Either this or this, it's the same. So that is like the opposite of what you have on the table. For example, you have 1, you will make it 0, so it's the opposite. So that's the negation of what you have. Next one will be called the disjunction. What is the disjunction? Disjunction is usually labeled as this or this. Okay, so for example, we have Q disjunction R, right? Or let's say Q disjunction P. So what we're going to do is, since we're comparing values, if for example Q is 1 and P is 0, it will be 1. Okay, as long as the truth table row has a 1, it will be automatically 1. So either, even if it's 1 1 or 0 1 or 1 0, that will always be 1. The only time that it gets to be 0 is when it's all 0. Okay, I like to call this the optimistic one, since it's like whatever, as long as it has 1, it will always be 1. Okay, it's the positive one. Next one will be the negative guy. This is a tip that I have, that I think about when I try to do the truth table. Negative because it's called a disjunction. It's called disjunction. Okay, this one conjunction negation. Okay, disjunction because it's a condition wherein if P or Q has to be only both 1 for it to be 1. Okay? So, for example, if you have around 3 variables, it all should be 1 for it to be 1. If one of them has 0, then the answer will always be 0. As long as it has 0, it will be 0. Okay? So always remember, this is the negative guy. I like to call him negative guy because he has like a negative side wherein if there's a 0, it will always be 0 already. So think about that. The exclusive OR. I like to call it exclusive OR. Because it will be written as this symbol, like a crosshair. P or Q has opposites, like they're alternating, like 1 0 0 1. It will always be 1. It will only be false if it's both the same. If Q and P are both the same, like they're all true or they're all false, it will always be 0. Always remember, if they are alternating or different, like 1 0 or 0 1, then that will make it always 1. Okay? Then we have another one this time. It's called biconditional. This time is the opposite of this exclusive. Biconditional, this time it should be the same. Like for example, Q or P. Okay, if it's 1 1, then it's the same because it's the same, right? True and true, then it will be 1. How about false false? It will also be 1 also. Okay? But if it's 1 0 or 0 1, this is the time when it will be 0 or false. Okay? So let's try this out. So we have PQ here. So let's use a conjunction. So notice, right? So since we have 1 1, this will always be 1. 1 0. You see that? This isn't both, or it already has 1. So true, so it will be true already. The same applies here, since it has 1 to be 1. This one has no 1, so it'll be 0. Now we will go to the negative guy or the disjunction. 1 1. Yep, it's 1 or true. 1 0. Since there's already a false there, this will be false. Okay. 0 1. It has a 0 already. Remember, negative guy, so he's already a 0. So again, 0 0, so 0. Okay. Let's test the exclusive OR. Exclusive OR is, that will be 1. So 1 1, it's the same, so it's 0. 1 0, it's different. 1 different. 1 the same. 0. Okay, gets. Then next one is biconditional. P Q has to be the same, right? Always remember, these are the only things that we are going to compare, these two, not these. Okay, So 1 1 is true since the same, different 0, different 0. 0 0 is the same, so it's 1. Last one is the not. So how do we do this? So for example, not P, what you would do is just make it opposite. Since it's 1 1 here, right? You make it 0 0 here. You see 0 0 1 1. That's simple. So of course, again, you can always make the 1 true, 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 false, 0 less false. It depends on your interpretation or whatever the teacher decides to use. But if you want to go with IT, I would prefer the 1 0 since it's related to the course. But yeah, true, false is the same. And I hope you all learned something today. Alright, goodbye.